Hi, welcome. In this video, we'll solve problem print all subsequences on backtracking. Now let's start backtracking concepts from this problem. If you are going to learn a backtracking path, this is the first problem that you should solve. Okay, so let's start. Let's start solving this problem. So here, what is this problem? It's all about print all subsequences. So now let's quickly understand what is the difference between these subsequences, what is a basic subsequence, okay, and what is the substring, right? What is the difference? So substring, or for arrays it is known as subarray. What is the difference? Okay, so let's take one example here. Okay, that I have a b c d. This is my one string. Okay, let's suppose s. This is my string s. Okay, now if I talk about the substring of a b c d, it will be a b, then a b c, then a b c d, then b, then b c, then b c d. Similarly, then it will be c, c d, and last is d. These all are substrings. Okay, so what is here in this substring? Basically, these all are continuous. Okay, and the relative order, okay, the order is also maintained, right? So the relative order is also maintained, or you can say simply order is maintained. Maintained, that means you can see here a is there, then b. Okay, after a then we have b, then after b we have c, then after c we have d. So you can see the same order in all these substrings, right? You can't see something like this dc. Okay, that is not a substring. Now what are the subsequences? Subsequences is basically refers to the sequence, right? It need not to be continuous. Okay, need not to be continuous, but here as well the order is maintained. Order is maintained here. Okay, so basically if I'm saying need not to be continuous, that means I can ignore b. So if I'm ignore b, it can be ac, it can be acd, right? Also I can ignore c, so it will be a b d, or suppose a d only. Okay, d, I can ignore d. So if I'm ignoring d, that is the case of substring only, right? But these ac, acd, abd, right, ad, ac, acd we have already taken, right? Ad we have taken. Okay, yeah, I guess we have taken all these examples. So in subsequences, these will be the terms plus these, right? The remaining, I am adding the plus all substrings will also be there. All substrings will also be there. So this will also come in subsequences, and this will also come, right? So remember, right? It is with these sequences when I'm leaving the character plus substrings, right? So let's take one one string, that is a b c. If I generate all the possible subsequences, it will be a, right? Then ab, then abc, okay, and then ac, okay, then b, then bc, then we will have in the last c, right? So you can see this extra ac is one of these, right? One of these subsequence that is different from the substring, but all these can be seen as subsequences. Okay, all these can be seen as subsequences. So I hope this is clear to you. What is subsequences, right? What is substring? What is the difference between subsequence and substring? This should be remain, right? Order is maintained in both the substrings and subsequences, but it should be like subsequence need not to be continuous, and substrings subarray should be continuous. Okay. Now let's see how we will print this. how we are going to print subsequences. So you can see here when I am talking about ABCD, okay, what I did, I ignored B character. I ignored B character and I checked with AC, right? And I said AC or D, okay. Or in the second case, I ignored C character. I took AB, then I took ABD. I ignored completely C. So we will also apply the same technique, okay, that is the pick and not pick, okay, pick and not pick, okay. And this is one of the famous technique, right? One of the famous technique in recursion backtrackings, okay. So you should know about it. So what I will do, I will give you a demo with the, let's suppose we have an string of A, B, C. This is my string. If I write the indexes, it will be 0, 1 and 2. Okay, these will be the indexes. Okay. Now let's see. So we have an empty string. Okay, I will start with an empty string. Okay, and what I will do, I will take a call on these strings. So let me create one complete boxes so that it will looks good. So let me quickly create it. So suppose we have an string. This is a string. Remember, I am putting this in boxes, but this is an string A B C. I'm putting it for a purpose so that you will get this thing. Okay. And suppose I is denoting to index. Okay. So on each I, whenever I am at I will take a call of should I take that character or not? Should I take that character, this character? Okay. Should I take that character or not? Okay. So suppose, right, I have a pick call, right? Pick and not pick call. So if I am taking A, right? If I am taking A, it will be A. If I am not taking A, it will be an empty string, right? So I have a call of A. So what I would do, I have done the two things, right? Now I will move ahead, right? Now again I have a call of B. Will you take B or not, right? So suppose if I am taking B, it will be AV. If I am not taking it, it will be A only, right? Here as well, right? With an empty string, if I am taking B, it will be B. If I am not taking A, it will be an empty string. Okay, I will move forward. I'll move forward. Now I have a call of C. So if I am taking C, it will be ABC. If I'm not taking it, it will be AB only. Similarly, if I'm taking C, it will be AC. If I'm not taking C, it will be A only. Similarly, if I'm taking C here, right, it will be C. If I'm not taking it, so it will be B only. If I'm taking C, it will be C only. If I'm not taking it, it will be an empty string. So you can see I have generated all the possible substrings, right? ABC, AB, AC, A, BC, B, C, right? This is all possible substrings, right? And how I have done it, basically on each indexes, I am taking a call of should I take it or not take it, but I am moving ahead, right? So you can see here, basically when was my ABC string, right? I have a pick and not pick call, right? So if I am taking a pick call, this is a pick call, okay, and this is a not pick call, okay. So you can see pick call, I have taken it, not pick call, then pick call, then not pick call, then pick call, then not pick call, then here pick call, not pick call, pick call, not pick call, here pick call, not pick call, right? So basically, if I just need to create two functions where I am taking pick call and where I am taking not pick call, and it will basically eventually generate all the possible substrings, right? So see, okay, let's consider once you have taken the call of C, your index will move, and this will be your stopping conditions. When your index reach to length, okay, that will be a stopping condition because you have taken the C, right? So here if I talk about the base condition, will be when my index is reaching to my s dot length, that is string length, will be my stopping condition or base condition. Clear? Okay, So this is how we will solve this problem. This is how we will generate all the possible substrings. Okay. So now let's quickly write the pseudo code of it. What will be the pseudo code? Okay. So if I write the pseudo code, so let's check the pseudo code. So here, let me create one function. Okay. Let me create a pen. So I have one function. Okay. Is sub for basically subsequences. Okay. And here that is in string. Okay. S, that is my string, that is given as suppose equals to ABC, that is given. Okay. And what I will do, I will take one index. This is my function. Okay. Now inside this function, what I will do, I will call two functions. Okay. Where I am considering, I am picking call. Okay. So one will be my pick call. Okay. So if I am taking this, it will be strs of index. Okay. Next will be s, my string, and I will move forward once I have picked it. So index plus one, because I have picked that. Okay. Now next it will be str when I will not pick it. So simple str, I'm not taking it. It will be s and it will be index plus one. Okay. So here you can see this is basically your pick call. When you are taking this, this is basically your not pick call. Okay. Not pick call. Okay. Once you have reached, okay, once your index is reached to the s dot length, what I will do, I will simply return it. Okay. So you can simply return from there. Okay. But what we need to do, we need to print it. So what you can do, you can simply print here. Okay. Print your str. Then you can simply return. Okay. So this basically this will be the pseudocode and this will work. Right. This will work. So what we will do, we will print all these substrings, right? So I will print in this order A, B, C, then A, B, then A, C, A, B, C, B, C. Okay. Now I'm just giving you one hint. Okay. Suppose in any particular condition, okay, you can see there are two function calls, right? One is the left one and the right one. And you want to print first A, then AB, then ABC. Okay. And then you need to print basically suppose AC. Then you need to print BC. Okay. Then B and BC. Then you need to print C. So if you can see, right, I have taken all the left function calls. This is the left one, left one, left one. Okay. Left one, left one, left one, left one. Okay. So if I am choosing only the left calls, A, B, I want A, I want AB, then I want ABC. Okay. Then I want AC. Okay. Then I want B, then I want BC, then I want C, right? So in this pattern, so basically this is my left function calls, only. So what I can do, I need to differentiate between these two calls, which is the left one and which is the right one. Okay. So let me tell you a bit changed version of this code. Okay. What I will do, I will create the function again sub. Let me put this here. You select complete. So sudo will come here. That means this till here. Okay. We this stuff. So here I have one function. Okay. That is subsequences. And I will pass a string. I will pass my string. I will pass the index. And I will pass, right, suppose is true or not, right? Okay. Is true or not, or is left or not. So I will pass is left here. Okay. Now what I will do, again the same function call. So I will do sub str. If I am taking it, it will be s of index. Okay. Then s, then index plus one. Okay. And if I am not taking it, it will be str s and simply index plus 1. Now what I will do, I will say I just need to want left function calls, right? Whenever there is a left function call, I want to. So what I will do, I will pass here true and I will pass here false, right? So if I am doing this one, okay, if in this condition is true, what I will do, I will simply print s, will print str. So I will print that function. Okay. And after this, what you can do, you can simply put your base condition. So after this, I will put my base condition here that if suppose my index is reaching to s dot length, what I need to do, I need to return from. So in that case, you will print all the substrings with the left function calls, right? And you can see these are in lexicographically, okay? But this will fall in one of the test case, that is a double a, right? So where if you suppose how you will start, you will take, if you will take a, you will get a. If you are not taking it, it will be an empty. But taking it, it will be a, then a, right? Then a, not taking, right? So basically it will work in this way. So you will say you will take this one a, then double a, and then it will come to this one. So your answer will be a double a, which is wrong. It should be a, then double a in lexicographically. Okay, I am talking about. Then what you need to do? You need to sort it. You need to sort this. That is also possible. Basically, whatever the you are string printing, you will simply put in an array, and then you can simply sort it. Okay, so that was the first version. Okay, I'm just exploring the all different version. First version, second version. Okay, and then we are talking about suppose one third version, right? Where instead of an substring, you have an array. You have an array of elements, 1, 2, 3. Then how you will do it? Okay, so now let's quickly see what is the basic problem statement. So I have an array. So let's delete an array. So now suppose if you want to find the subsequences of an array, right? So that means your one answer will be 1, then can be second 1 comma 2, then third can be 1 comma 3, right? 1 comma 2 comma 3, right? These all are answers. So you will generate subsequences of an array. Then how we will do it? Okay, exactly same. Okay, exactly same, right? If I talk about it, so let me quickly write the function. Okay, the pseudocode how it will be differ. Okay, so suppose if I am generating subsequences of an array, so what I will do again, I have one, suppose here we will take sub array, let's take sub arr, okay, and then you have this array and then you have the index. Okay, same calling, right? Now what we will do, because we need to put all these elements as well, right? So what I will do, I will push that into my one, you can say your resultant, right? So what you will do, you will take one resultant array, right, where you will push all these elements, right? So you have a sub array, you have already started sub array with an empty array. So if I talk about what will be my sub array, it will be an empty array. So sub array will be an empty array, right? Then you have an array, then you have an index. Remember, right, how I will call this function? Basically, if you don't know how I will call this function, I will call sub, right, with an empty string, then s, and then index will be 0. This is how I will call it. Okay, here as well, if I call it sub with an here empty string, okay, then s, okay, then index will be 0. In the starting, you can put anything, right? You can put true, false, whatever. Okay, suppose even I am putting false, we'll check it by no worries. Okay, so this is how you will print it. Okay, so what we will do, we will solve one problem on it. Okay, then you will get basically how the code will works. Okay, so what I was talking about, the subarray. So subarray is here empty, right? Then we have an array and then we have an index, same function calling. Okay, what I will do, I will simply call my two functions, sub one pick call and not pick call, right? So one pick call when I am taking it. Okay. So when I am taking it, I will write the same. So this will be my sub-array array index plus one. Suppose this is my pick one call. This is my not pick call. So you will say both are same, right? Both function call is same. So how I will differ it? I will simply say my sub-array dot push. I will push the current element, right? So ARR of index, I will push it, right? And here, once I will come back from it, what I will do, I will simply pop it. Subarray dot pop will be simply pop, won't consider any index, right? It will be pop. So again, you can see this is my pick call when I am picking it. This is a not pick call when I am not picking it. So this is my pick call. This is not pick call. Okay. And again, right? Basically, the conditions will be same, right? Whenever your index is equals to your array dot length, you will return. Okay, but before return, you have this rest, you will push your answers to the rest. So how you will push? That is rest dot push, and you will do triple dot the subarray. Why this one? Okay, let me tell you why this one. Now after this, what you will do, you will say return. This will be your function call. If I call this function, it will be sub with my subarray, empty array, subarray, then the actual array, and next will be 0. Now what I am doing this, why this is triple dot? Okay, see, if you are pushing this subarray, right, remember your array is keeps on changing, right? You will add 1, then you will add 2, then you will add 3 to it. And if you are simply pushing rest dot push subarray, so here you will have subarray, right? And it will eventually change because when I am pushing subarray, basically it is storing the address of the subarray, right? This will be a reference. So my actual subarray will keeps on changing. So what I need to do, I need to create a shallow copy of it. I need to create a copy of its subarray, right? So I will put the elements in the new array and then I will push it. So even in my recursion call, this answer won't affect. That's why I'm doing it. Okay. So I hope you are clear with these problems. Okay. We are good to go. We have solved so many problems. Now there will be one homework to you for this problem that is exactly same. Suppose this is the array and I want to find the sum, right? Now the sum can be 1 plus 3. Okay, and that is also possible. How I will take it again, that is, you can see 1 plus 3 is a sum of subsequences, right? So you can take this into consideration, right? And we will simply find sum basically by generating sum of subsequences. So I can take sum plus ARR of I, that will be my pick call, and if I'm not taking it, it will be simply sum call. Okay, so by this we can simply put it. Now let's talk about the time and space complexity. What will the time complexity? So see, here you are doing two function calls, right? And here also you are doing two function calls, right? So here two function calls, here now four function calls, here 8 function calls, right? So if I do this 2 plus 4 plus 8 plus, right, here in the next it will be 16 function calls, right? So it will go till infinity. Okay, if right, it will go till, right, till n, whatever the length we have. Okay, so it will not go infinity, but it go up to in terms y and terms c. So here we have a, then b, then c. So you can see, right, we have gone this one time, second time, and third time, right? 2 plus 4 plus 8, right? So it will go till n terms only, right? So only n terms. So now if you can see, this is the sum of your gp, okay, GP of finite terms, that is up to n. Okay, up to n. So if I am talking about this one, what will be the formula of GP? That is A, okay, R power n minus 1 upon, I guess, R minus 1. Here R is not equals to 1. So here R is 2 when I'm doing two function calls, right? It will be 2 power n minus 1 upon 2 minus 1. That is basically 2 into 2 power n minus 1 upon 1, right? So if I am taking the higher order terms, I can simply ignore this minus 1, right? Because 2 into 2 power n is a very big term, right? So yes, the time complexity will be order of 2 power n, right? Because, right, it will go till 2 power n. Why? Order of, again, remember order of. And I'm taking order of, that means, okay, it is comparable, right? So when I'm taking order of, because here two function calls I am getting. Similarly, right? Similarly, suppose if I am getting three function calls, right? From each direction I am getting three function calls. So it will be 3 power n, right? Now what will the space complexity? So space complexity will be the recursion stack, right? So this basically I will call this function, then I will call this function, then I will call this function. So okay, it will be the longest function call in a particular, you can say, edge, right? So here you can say this is the longest function call, this is also longest function, all function calls are longest, right? But the maximum function calls we can get, that is the till any of the, right, from root to leaf, right? Any of the root to leaf, longest path will be the function calls. So it will be not greater than n times, right? So we go of, right, one function call, second function call, third function call. So it is not greater than, we go of n times. So it will be time complexity will be big of 2 power n, and it will be big of, okay. So that's it. That's all about how we can generate all the subsequences. I hope you got a complete clear understanding, and that's the first problem on backtracking. Okay, from here things will be changed, things will be around how we again backtrack to it. Okay, so that's all about this problem. In the next video, I will give you a code implementation of one particular problem, how you can simply implement the code, and then we will do a bit of dry run, basically how our code works, how the recursion stack works. Okay, so see you in the next video where I will apply the code.